Okay, sir.
So, how are we supposed to go ahead? This is SHM lecture number 2. And in the previous lecture, we were dealing with the equation of simple harmonic motion. Most of the question that we guess or we suppose that they are going to come is going to come from this particular section only, because this is the section where they can make good questions and simpler ones, and the ones which check your concept a lot. In the previous class we had seen what is the equation of SHM, how or what are the different ways in which you can write that equation, what are the different terms that appear into that equation, remain mainly phase difference, and we have understood how we can write the equation of SHM in different ways. If the SHM starts from one position, how do you write it? If the SHM starts from the next position, how do you write it, and so on, right? Do we remember this? If the SHM starts from one extreme position, how do you write the equation of SHM? If it starts from the other extreme position, how do you write it? And I think I had given you a question which you were supposed to solve. So we will start this class with the same question. And this is the question. A particle execute SHM of time period t. You were supposed to find the time period it takes to move from the extreme position to the position where the amplitude is a by 2. Now, how are you supposed to solve a question of this nature? Yes. Did you try it?
అయిపోయినాం కదరా.
Did you try this question?
Yes, sir.
Okay. How
Sir,
did you get the answer for this one? Yes, tell me.
sir, we can consider that the SHM is starting from either side, maybe from the left or right side. I
Okay.
have considered it from the right side, that is phase is pi by 2.
Okay.
At t equals to 0, its phase is pi by 2, and at t equals to some, after some time, it is at a by 2. Then I got the phase as 3 pi. I got the phase as 5 pi by 6. So I have used that phase difference by 2 pi equals to time difference by t. I got that time taken to be 1 by 6 of t.
Okay. I think I have understood what you are trying to say. Let me add my comments onto it. I think what you have done is correct. Now, since we know, we have to find out the time it takes to go from the extreme position to the position where x is a by 2. Now, if I just go back and if I have that diagram, where is that diagram? If I have that diagram, it will become easier for me to make you understand. I think the diagram was here in this only. So let me take this diagram from here. Let me take this diagram from here and try to make some sense here. Okay, now this is the diagram. Remember, this is a sine wave. A cos wave is same as sine wave. The only thing, it does not start from 0, it starts from the highest point. Doesn't matter, the concept remains the same. Now what you have to find out is the time it takes to go from one extreme position. Now remember, when it is here, it is at the mean position. When it is here, it is at the extreme position. On one side, you can call it the positive side. When it is here, it has come back to its mean position. When it is here, it has gone to the extreme position on the other side. And when it is here, it has again come back to the original mean position. Now I had, remember, this is a sine wave, and a sine wave is symmetrical. Whether it's a sine wave or a cos wave, a sine wave or a cos wave is symmetrical. Doesn't matter from where to where you find it's a symmetrical wave. Now what they have asked is you have to find the time taken to go from extreme position one extreme position. So let me call this position as the extreme position. They want me to find out the time taken from here to the time where the amplitude becomes, or the value of a becomes a by 2. So basically I'm supposed to find out this time t. So basically I'm supposed to find out this time t between these 2 points. Do we understand this, or this has gone above our heads?
Understood, sir.
Now, whether I find out time from here to here, or if I, remember this is a symmetrical wave. So if I find out the time from, if I call this point as A, if I call this point as B, and if I call this point as C, time taken to go from A to B will be same as time taken to go from C to A. Yes or no?
Yes, sir.
So it doesn't matter which time I find out. I can find out the time from C to A. That is as good as finding out the time from A to B, because it's a symmetrical wave. Similarly, if I call this point as B, if I call this point as D, time taken to go from B to D will be same as
Time taken to go from that initial to C.
initial to C. So because you have to understand that this is a sine wave, and a sine wave is symmetrical. Yes or no?
Yes.
Now, to find out this time t, which I have to find out from A to B, what do I do? Now, either I use the sine wave and then find out the position, or I just start my wave from A. And then it becomes easier for me to find out this time t. Now, if I have to start my wave from A, which is the extreme position, which is the most convenient equation that I must take so that I start my wave from A. The most convenient equation is x is equal to A cos omega t. Yes or no? At time t is equal to 0, I am at the positive extreme position. Do we understand this? Yes or no? Now, the time it takes to go from A to B, I just have to put the value of x as A by 2 and I get my time. I just put the value of x as A by 2. A by 2 will be A times cos omega t. That means your cos of omega t, remember it is in radians, cos of omega t becomes half. So your omega into t becomes cos inverse of half. What is the cos inverse of half? It is pi by 3 radians. Yes or no? 60 degrees. Cos of 60 degrees is half. Do we understand this, or this is going above what it's saying bye bye?
We got it, sir.
Now this omega is 2 pi by t. So 2 pi by t, capital T, into t is equal to pi by 3. Pi say pi will get cancelled, and you will get your answer as t by 6. This is one way of doing it. The other way of doing it is the way that you have told me. You can find out the phase of the particle. The phase of the particle is pi by 3. From the extreme end, the phase is pi by 3. From that phase difference, you can find out the time difference. A phase difference of pi will give you a time difference of t by 2. So a phase difference of pi by 3 will give you a time difference of t by 6. So that is the next way in which you can do this. You do it in this way or you do it in that way, you must end up with the same answer. Do we understand this? Yes or no? Okay, I'll give you 2 minutes to note this down. Note this down, and then we'll come back. Now, if I ask you to find out the time taken to go from B to D, what is your answer? Now remember, you have to understand this is a sine wave. And I have told you everything that you need to know. What is the time taken to go from B to D? Yes, my dear bacha. Any hope?
Sir, it is T by 12, sir.
It is T by 12. How did you get T by 12?
Sir, it is symmetric, no, sir.
It is
So
symmetric, no, sir. Yes.
from A to D, it is T by 4.
Yes.
It is T by 4, and that A to B is T by 6, and B to D is some T. Let's say some T. So T will be equals to T by 4 minus T by 6.
That is correct. So that is another way of doing the same thing. So basically what it means, if I just enlarge the view, and I hope you can see the enlarged view. Now, remember this is a sine wave. This is the point A. This is the point B. And this was the point D that I was talking about. You remember, I told you from here to here, the total time will be T by 4. Yes or no? Yes or no?
Yes, sir.
From A to B, you have already calculated the time. It is T, oh, not small t. It is capital T by 6 from A to B. So you can now calculate this time. The small t plus T by 6 must be equal to T by 4. From there, you will get the value of T. What is the value of T that you are getting? T by 12. Is that so? Huh?
Yes.
But that is not the only way of doing it. There are 10,000 different ways of doing it. 10,000 different ways of doing it. I had marked this point C, and I had marked this point O, and I told you time taken to go from O to C will be huh?
Time taken to move from B to D.
You can also find the time taken to go from O to C very simply. How? Now you can use the other equation. You can start the equation from point O. So now you can write the equation like this: x is equal to A sine omega t. And that is the faida of understanding this equation of simple harmonic motion. Now you can use x is equal to A sine omega t. This one. And as soon as you put the value of x as A by 2, A by 2 will be equal to A sine omega t. From here, I can get the value of omega t as sine inverse of half, and sine inverse of half is pi by 6. The phase difference is pi by 6, so the time difference has to be t by 12. Or you can put omega as 2 pi by capital T into small t is equal to pi by 6. Pi se pi getting cancelled. You will get t is equal to t by 12. Do we understand it, or this is gone above or saying bye bye, sir? Ho gaya. Done. Done. Finish. Finish. Huh?
We understood.
I'll give you 2 minutes to note this down. What we have discussed is the displacement as a function of time, or the position of the particle. Displacement may not be the right word, but everywhere it is written as displacement, displacement, displacement. It is actually the position of the particle as a function of time. Now that is not the only thing that might be asked, and that there could be the next thing that comes in. What is the next thing that comes in?
Velocity.
Velocity of a particle executing SHM. Velocity of particle in SHM. So that would be the second. Velocity of the particle. So what is this velocity? It is the rate of change of position, right?
Yes, sir.
Many of the books will say it is rate of change of displacement. but don't trust those books. It is the rate of change of position of the particle as a function of time. And that x was actually the position of the particle from the mean position. Now, how will you find out the velocity of the particle? You know, if I write the equation, and the most general equation will be written as sine of omega t plus phi. Do you understand the meaning of this sine omega t plus phi and writing the most general equation? Yes or no? No or yes? Huh?
Yes, sir.
Then my velocity will become the derivative of this, and the derivative of this will be a omega sine of omega t plus phi. We understand this?
Yes, sir.
Now this a into omega, this a was the amplitude of displacement, or the maximum value of displacement. So what is this a omega? This, what is this a omega? This would be your maximum velocity. So I can write this v as v max, maximum velocity sine of omega t plus phi, where your v max is nothing but the maximum velocity of the particle. And where does this maximum velocity of the particle come? Where does the particle have maximum velocity?
Mean position.
Yes, it comes at the mean position. You put the value of t as 0 and you will get this maximum velocity. So it comes at the mean position. Do we understand this, or this is going above our head saying bye bye? Now, in simpler terms, if you forget about that initial phase, if initial phase is taken as 0, then you will have very simple form of equation. Your x will be written as a sine omega t, and your velocity will be written as a omega cos omega t. I'm just avoiding that initial phase. That does not make much of a difference. Do we understand this? Yes or no? No, yes. Huh? Now,
Velocity formula, sir.
what
Sir,
happened?
I think in velocity equals to dx by dt, you have written sine, that may be cos.
Oh, yes, yes, yes. Sorry. I have written sine, it would be cos. Okay, so here I have written x as a function of time. Here I have written v as a function of time. Do we understand this?
Yes, sir.
X as a function of time and v as a function of time. I can also write v as a function of x. I can also write v as a function of x.
dx by
Can anyone tell me how I can write v as a function of x? V will be
dx
equal
by
to,
dt, sir.
that is as a function of time, beta. How can I write v as a function of x? X. So I can write this as a omega into cos omega t. You can find out the value of cos omega t from sin omega t. A omega into root over 1 minus x square by a square. Yes or no?
Yes, sir.
Yes, sir. This is simple trigonometry, sir. So ultimately, you will get this result. 1 omega will be left, omega into root over a square minus x square. Do we understand this? Yes or no? No, yes. Huh? So you can write it in this fashion also. V square by omega square plus x square is equal to your a square. You can also write it in this fashion. And as soon as you write it in this fashion, bacha, what does this equation represent? Huh? What does this equation represent? If you don't understand it, I can also write it like this. V square by omega square a square plus x square by a square is equal to 1. Now does it ring a bell? Ring a bell, ring a bell, ring a bell.
Ellipse, sir.
Ellipse! Our old friend, which was coming in gravitation. Old friend, ellipse, comes back with a bang this time. Ellipse comes back into the picture. Ellipse, ellipse. Don't forget ellipse. Our ellipse, your ellipse. What is the eccentricity of an ellipse? Huh?
Under root 1 minus b square by a square. If
Is it less than 1 or is it more than 1?
sir,
Is it less than 1 or is it more than 1?
it is between 0 and 1, sir.
Who has got the eccentricity equal to 1?
Circle.
Who has got eccentricity equal to 1?
Rectangular hyperbola.
Equals to 1. 1 minute. ఒక్క నిమిషము. Parabola y square x square equals to
Who has got eccentricity equal to 1?
parabola, sir.
Parabola, sir. That is correct, sir. Parabola has got eccentricity 1. Who has got eccentricity 0?
Circle, sir.
Circle, sir. Can this parabola become a, can this relation between v and x can become a circle? Under what condition can it become a circle? This, gentlemen, can it become circle in any case?
Omega equals to 1.
Omega equal to 1. Yes, that is correct. If omega is 1, then it becomes a circle. Well done. If omega is 1, it becomes a circle. Do we understand this? Bye bye. Bye bye. We understand this, or it is gone above it saying bye bye?
Understood, sir.
Then the next point is the velocity of this particle in SHM can be towards the mean position. It can also be away from the mean position. Because sometimes it is moving towards the mean position, sometimes it is moving away from the mean position. And at the mean position, the velocity is maximum a omega. And at the extreme position, the velocity is 0, which is the minimum possible value. Do we understand this, or this is going above our heads? Saying bye bye, bye bye, bye bye.
Understood, sir.
Pakka na sir?
Yes, sir.
Who has got eccentricity greater than 1?
Hyperbola.
Hyperbola.
Hyperbola. And what is the trajectory of the particle when the velocity I gave it is more than the escape velocity? What type of trajectory it follows? At any height, if I give it more than the escape velocity, what trajectory will it follow?
Sir, it will be straight line. More than escape velocity. More than escape velocity అన్నాడు సార్. అదే కన్ఫ్యూజన్ కదా.
Confusion jhala.
Sir?
Confusion. Everyone is confused. In life, everyone is confused. No one knows anything. Okay, I did not give you that concept. Oh, my mistake. My mistake. My mistake. My mistake. My mistake. Okay, have you noted this down? I will get back to it. Get back to that.
1 minute.
I missed a point, it seems. My mistake. If it is your mistake, then you can't blame anyone. It's definitely my mistake. Okay, but I can always rectify my mistake. And once you rectify your mistakes, you become better. You must always rectify your mistakes. Yes. Have you noted this down? What are you noting down, by the way? What are you noting down, by the way?
Last point, sir.
Last point, sir. Last.
Done, sir. Done, sir.
Done, sir. Well done, sir. Now I take you back to the chapter on gravitation. And this is probably what I missed, or what I forgot to tell you. The equation of what will be the path of the projectile if I give it different velocities from from the same point. Now I have taken it at a distance h or height h from the surface of planet Earth. Now at this height, I have something which is known as VO. You understand the meaning of VO? What is VO?
Orbital velocity.
Orbital velocity. So if I give it exactly at this height, if I give it the orbital velocity, I think I had done this. If I give it the orbital velocity exactly equal to the orbital velocity, it will follow the path of a circle. I did not discuss it in this class. Why
No,
do
sir.
In which class did I discuss this? If I give it exactly the orbital velocity, it will move in a circular path. V is equal to V naught. It moves in a circular path. Yes or no?
Yes, sir.
If I take it to the height and give it zero velocity, if I give it velocity 0, what happens? It will just fall back on Earth. Yes or no?
Yes, sir.
If I give it a velocity which is less than the orbital velocity, it will fall back on Earth, but it will follow an elliptical path, and Earth will be the farther focus, and therefore it will just fall back on Earth, and it will not be able to keep on revolving around Earth. So if V is less than your orbital velocity, it has to fall back on Earth following an elliptical path. What happens if your velocity is more than orbital velocity? So this is the case, the pink case. In the pink case, your velocity that you give is more than your orbital velocity. but less than your escape velocity from that point, from that height, whatever is the escape velocity. If you give it that velocity, then it starts to orbit around Earth in an elliptical orbit, and this is that elliptical orbit that you see, and Earth is at its nearer focus. So when Earth is at its nearer focus, it will keep on revolving around Earth in an elliptical orbit. Eccentricity is less than 1. Earth will be at the nearer focus. In first case, when the velocity is less than the orbital velocity, Earth is at the farther focus, so it will fall back on Earth, following an elliptical path, that green path. Do we understand this?
Yes, sir.
This green path, it will follow when your velocity v is less than orbital velocity. This red path, it will follow when the velocity is 0. It will just fall on a straight line. Just fall in a straight line. If it is less than the orbital velocity, it will follow an elliptical path, but it will fall back on Earth because it just cannot revolve, because the path will cut the surface of Earth. It will fall back on Earth. If you give it a yellow velocity exactly equal to the orbital velocity, it moves in a circular path. If you give it a velocity more than the orbital velocity but less than the escape velocity, it will move. It is bound to Earth. It will move in an elliptical path. Earth will be the nearer focus. Now comes eccentricity 1. Eccentricity 1, that means you give it a velocity which is equal to the escape velocity. It will leave Earth in a parabolic path. Eccentricity is 1. Escape velocity is eccentricity. It will leave the Earth in a parabolic path. If you give it a velocity more than the escape velocity, hyperbola, eccentricity is greater than 1. It will leave the Earth in an hyperbolic path. Eccentricity 0, circle. Eccentricity less than 1, ellipse. Two cases of ellipse. Nearer focus, farther focus. Eccentricity 1, bye-bye, parabola. Eccentricity greater than 1, bye-bye, hyperbola. You understand this, or this has gone above our head saying bye-bye?
Understood, sir.
No, not bye-bye. Understood. Congratulations then if you have understood this. I'll give you 1 minute to note it down. I missed it, so just write it down. You never know. It may just come in your exam this time. I'll give you 2 minutes to note it down. I hope you understand the meaning. Yes or no?